All right, today we're going to talk about section 6.8, analyzing graphs. Attention up here, please. First thing, just like I've kind of been saying all chapter, if I tell you that something is a zero, a factor, a solution, or an x-intercept, I'm talking about the exact same thing. It just may depend on the context of the problem, on what I'm asking for. But a zero, we've been working with these for a while, using that synthetic division, or finding a zero to help us find a factor. That's why we have that x minus some number. You guys also know that your zeros and your solutions, they're the same things. Set everything equal to zero and solve. And the last thing we're going to talk about today is going to be x-intercepts, and we're going to use those to help us. So we're going to have some graphing today. So if we're going to graph the function f of x is equal to 1/4 times x plus 2 times x minus 1 squared. What we're really talking about, that squared, is 1/4 times x plus 2 times x minus 1 times x minus 1. Meaning that we've got that repeated roots. We talked about those last week. These all look like just factors, right? Something you guys would have created using your synthetic division, plugging in -2 and 1. You'd be able to factor that. Okay? So x minus what number is going to give me this plus 2 right here? To -2. Okay? So these all happen to be from this last slide. Since you guys know that these are factors, they're going to be an x-intercept too. So that means I have x-intercepts at -2 and 1. So right on the x-axis at -2, right on the x-axis at +1. So, okay, that's nice, but that's not going to help us graph a whole lot. That is not the graph. So, how might we find more points to help us graph?
Plug in a different number.
So, we're going to get an XY chart. And we're going to pick some different values. Okay? If you're going to use your x-intercepts to graph, and today we're going to get a little more than that. But I for sure want one to the left of your farthest x-intercept, one in the middle of your x-intercepts, and one to the farthest of your right. So if you end up with 3, you'll have more points in the middle. So going to the left, I'm going to pick -3.
0.
In the middle, I'm going to pick 1 and 0. Oh, that's supposed to be a -1. I'm sorry.
Dang it, Mr.
So, and why do we not have to check 1?
Because it's already there.
It's already there. We know what it is. That's one of our x-intercepts. And then I got to pick, I'm going to pick 2 and 3. So, since why and 3? Because I can.
Oh, we don't have to.
So, no, I would be fine if you stopped at -3 and 2. So, make sure you give me some points in the middle, though.
In the middle. In the middle of the 2 points.
In the middle of the 2 blue points. You could have just done 0, yes. The more points you have, the better your graph will turn out. What's that? You want 0.27?
How do you know exactly?
So, So, you know, since I have 3 x's being multiplied here, 1, 2, 3, I've got an x cubed graph. So that should tell you what your ends will do. And then we're going to check points in the middle so that you know what it's going to do in between those ends. So, let's do -3 together, and then we will divide and conquer to get the other ones. So if I'm going to use -3, I'm going to get 1/4 times -3 plus 2 times -3 minus 1 squared. So I just plugged in to the formula at the top here. So it's just going to multiply it at the end. So you're going to get 1/4 times -3 plus 2 is -1, and -3, -4 squared. 1/4 times -1 times positive or -16? Positive 16. Good. Since that negative is inside your parentheses there, then you will get a positive 16. Yep. So you multiply -1 and 16 to get -16. Take 1/4 of that to get -4. So now we've got the point -3, -4. -3, -4. It's going to show up right there. All right. Let's divide and conquer this a little. All right, so at -1, you should have gotten 1. At 0, you should have gotten half or 0.5. At 2, you should have gotten 1, and at 3, you should have gotten 5.
Oh, I know what it is. No, I think that right. What did I do wrong? Oh, correct square.
Okay, so I go -1, 1 up here, 0, 1/2, 2, 1, and 3, 5. Now, obviously, if you want more points on the end, you're more than welcome to do that. I will not stop you there. More points, exactly, why would I? The more points, the nicer your graph is going to end up looking. But now we are just going, well, we haven't connected the dots yet.
I did.
Okay, so our graph starting from the left is going to start low. It's going to go through this point. It's got to hit all of our points there. And it's going to finish high. I did. That's it. Okay. How did I know that the graph just touched right here and then went right back up? So that is, what if I would have checked like 1.5? Then I would have had to hit that. Okay. The reason I knew that it didn't go below again is because there's no x-intercept farther to the right of that. All right. Then some vocab for you. First thing we want to talk about, turning points.
Wow.
Yep. So this is where the graph changes direction. And what I mean by that, okay, right here, our graph goes from going down, or from going up from left to right here. Now all of a sudden, right around 1 or -1, now it's going to start going back down. Right around -1, that's where your turning point's going to be. So the graph turns. So local maximum, that is the y value of the turning points and since it's a maximum, it is going to be higher than all other nearby points. Now, there's a reason it's a local maximum. It's just the nearby points. It's not saying that that is going to be the highest point on the graph. If you look at this graph down here, this local maximum right here, obviously that's not the highest point on the graph. You guys can see there's a point up here that is higher. But in that little area where that turning point occurs, then that is the local maximum. So it's not what's called a global maximum. Then a local minimum, again, is the y value of the turning points this one is going to be lower than all other nearby points. Again, it may not be the global maximum, it may not be the lowest point on your graph. Down here is lower than our local minimum, but it is lower than all of the other points that are close to it in that neighborhood. Then, when we're talking about turning points, a graph of every polynomial function of degree n, so some number, whatever degree it is. Remember, we're talking like degree 3, degree 4, 5, whatever. Yep, those are all degrees. Okay? It's going to have at most n minus 1 turning points. Okay? Right there is the key, n minus 1. Then, if it has n distinct real zeros, so if it's degree 3 and it has 3 real zeros, 3 x-intercepts, then its graph has exactly n minus 1 turning points. So, if it is degree 3, how many turning points would I expect to see, Landon?
2.
Good. Okay?
I think I was there for you, Landon. Oh, I know.
Okay, so your turning points are going to be one less than whatever degree it is. Now, if you see 2 turning points here, what degree are we working with?
3.
3, okay? So it can go the other way too. So if you see those 2 turning points, you're going to work with a degree 3. Okay. We're going to graph each function, then identify the x-intercepts and points where the local maximums and local minimums occur. Okay. I have all the faith that you guys could graph this, but let's make this easier on ourselves.
Graphing calculator.
Yep. We're going to use Desmos. Okay. Okay, x cubed minus 3x squared plus 2. Okay, so